Well, Bruce Goff is an architect, and I think he holds the distinction of being probably a unique architect due to his imagination and creativity. This has led to his teaching in almost every major university in the United States, and also in other countries such as Japan and Australia and various European countries. And there's something, though, that some people may not know about Mr. Goff, and that is that he has been and still is a wonderful teacher. And that, in fact, there's a new issue of a Japanese magazine called A+U that has just been published, that's devoted to graduates of the School of Architecture from that period of time when Goff was director of the school. These people are now mature, practicing architects, and you can see in their work a continuation of this imagination and creativity that I mentioned before. And there are a number of people who have given a great deal of recognition to this, and especially, I think, in Japan. In fact, the magazine is a Japanese magazine. And I would think it's important that other people realize what a contribution that Mr. Goff has made to teaching. And I'm very proud of the fact that we have him with us now for this year as a visiting distinguished professor, and have an opportunity for students to be exposed to his teaching again. And I deem it a great privilege to have been associated with him in the past and to be able to share some time with him now.
I think it's quite an honor for me to be here, and not only Mr. Goff, but also Bill Wilson, because frequently the, quote, architect of the job gets many of the accolades, which are quite appropriate in Mr. Goff's case, but I think also there's somebody else that assists him and helps him, and without that part, many of these excellent imaginative pieces of architecture could not have been built. They would have stayed on the drawing board. So much in the same, not necessarily totally the same way that Commandant worked with Kant, but I'm quite sure there was some relationship between both of you, that you facilitated certain ways of designing or making or constructing things which may not have been in the vocabulary of Mr. Goff. And I'd like to ask you both some questions to see how you both work together. It seems to me your personalities coincide, and I've known you for a little bit of time now, and somehow you both seem to have the same sense of humor. So in that respect, I would like to ask you, when or how, what was your level of communication when you were working on some of these houses? For instance, the Cox house or the Taylor house. What was your main means of communication?
Well, the Taylor house came first, so let's take it first.
All right.
And it was really the Ledbetter house at the time it was designed. And I was still a student here in the University of Oklahoma, and World War II had just ended. And Bruce had designed this house, and he had the drawings in his office, and a number of students were looking at the drawings, and I was among them. And finally he turned to me and asked me, he said, well, what do you think of it? And I was very much fascinated by these discs that were suspended out in front of it. Here were these discs, you know, about 16, 18 inches thick, 30 feet in diameter, 360-degree cantilever, all suspended from one point, and I'd never seen anything like that before. And this was a little bit before UFOs had come on the scene. And so I asked him, I said, well, what I'd like to know is, how do you intend to build these discs? And he laughed and he said, well, I thought I'd get you to do that. And this worried me a great deal. And I didn't sleep much that night thinking about these discs and finally an idea came to me that if we took a piece of pipe that was about the same length as the thickness of the disc and welded some flags on it at various angles, that we could bolt members on those quite like an open web joist and have them taper down to a thin edge. And if each one of these were on a radius of the circle, we could generate this shape. So I took the idea into him the next day, and he looked at it and he says, well, I think that's fine. He says, now why don't you make these things? And so I got a group of students together who were very eager to participate in this. And we found some aluminum at a war surplus yard in Oklahoma City and got access to a garage that was big enough to build a 30-foot circle in. And got started. The students did the work on the fabrication. And when we got the framework put together, well, we went over and asked Mr. Goff if he would come over and look at it. And he did, and we showed him the framework. And in the original drawings, these discs had a skin on the top and another one on the bottom. Well, we'd already put the skin on the top, but we'd left the one off the bottom until he had okayed the thing. And he came over and he looked at it and he says, you know, the structure looks good. I think I'll leave the skin off the bottom. And that actually led to this association we had for about 6 years. And to tell you the truth, Bill, we rarely ever talked about these things. He designed them, and then he would show it to me. He would never discuss one of these projects during the design stage, and I knew better than to ask him questions. I just stayed away until he had the idea all down on paper. And then we'd have a discussion, and most of the time they were so self-revealing that I didn't have to ask very much. But occasionally I'd ask him about a material here or one there that I wasn't sure of, and he'd tell me what he had in mind. And then I would see if I couldn't get it worked out to where it was buildable, and that was surprisingly easy to do. A lot of people think that the engineering for the Goff house was difficult, but actually it was always so logical and straightforward. And the structure and the technical parts of it were already a part of the design. And really, I don't think that I was much more than a technician just to work these things out.
Well, you did all the calculations then, is that correct?
Yes, but you see, they always worked out. We just never had to change anything. His intuitive sense of structure was so good that all I did was just simply use the calculations to verify the decisions that he had already made.
Well, that's what I wanted to know then. So then, how did you have the intuition then to design these things on paper? Did you make models?
No.
You never made a model of anything?
Never.
So then, your ability to draw and your ability to imagine these things, but what made them so logical and so correct?
Well, probably because if they were logical, I had a very early start in architecture. As you know, I was apprenticed when I was 12 years old by my father, and to a firm of architects, of course. He was not an architect. But this was a very good firm, and one of the principals of the firm was the engineer, Mr. Endicott. And in those days, if you were apprenticed, they tried to teach you something instead of just putting you in the back room and having you draw stairways or toilets or something no one else wanted to do. And so he did give me some appreciation of the need to think of things structurally. At that time, very few architects worked directly with engineers or with their own firm in the design of steel and concrete and so on. Usually that part of the work was farmed out to the steel companies or to the concrete companies or somebody, and they always saw that there was plenty of beef in them so they could sell more steel or more whatever they were selling. And as a result, most of the frames and structural members looked unnecessarily heavy, and were. And Mr. Endicott took the position that the structure should be strong enough, but it had to be strong enough to have a factor safety of 4 usually, which seems plenty. But at the same time, he thought it was just as big a crime to over-design it for it as it was under-design for it. And so his working structure always looked quite light compared, because he did his own structure, you see. It always looked quite light in comparison with other architects who had their steel done by the steel company. And so I got used to thinking of the importance of structure. At that time, the schools were teaching that the only thing that mattered was the pretty picture attitude towards architecture, to try to do it the way the Greeks had done it, or the Gothic, or the Renaissance, or somebody else. But they all looked on engineering and structures as kind of a dirty word that was always in their way. They didn't know how to handle the design of a tall building at first, you know. They'd already begun to find that out by then. But Sullivan had taught them that. But that is to make a tall building look like it was tall and graceful, and have its style all the way up, and still not be following the orders. And you see, the only three, well, there were supposedly five orders that they had in architecture. The classical studies gave them, that the Greeks used. One was the Doric, and one was the Ionic, which boys in school always call the Ironic, and then Corinthian and variations of those, Tuscan and Composite. And when they'd have one style of this for most American buildings of any height. As they went up, they'd have the plain ones at the bottom and the fancier ones as you got up to the top. But after a while, they ran out of styles, you see, because the buildings would have to be higher than 5 stories. And so then they'd throw in 2 or 3 stories per order, and then finally they thought, well, the heck with it, we'll just have the bottom and the top and put the plain middle shaft up, you see, and punch that full of holes. Well, of course, this made me realize how ridiculous there was no coordination between usually what was structural and what was design. And the engineers hated the architects because they thought the architects were just prettying up, pasting decoration stuff over what they did. And the architects hated the engineers because they were always in their way with some fool structural thing, as they'd call it. So it was a battle that was going on, trying to reconcile the old styles of stone architecture to steel and concrete and so on. And so I learned right away that I had to learn something about that myself, or I'd be at the same mercy of these people that the other architects were. They're having to use way too much steel or way too much concrete or whatever. And then I'd run out of styles quick, you know, if I was trying to follow the Greeks. And so I had to think of things logically. And this firm was very good at working with details, making sure they didn't leak or that they would weather well without spilling dirty water all over the building and stuff like that. And So I had a healthy respect for this, although I had no schooling of any kind beyond high school. And any schooling I've had since has been on my own, trying to dig out things. But this was put into my head by the firm before I ever got out of there, to how to use what we call the Sweets catalog materials, all the terracotta, the stone, the brick, the glass, the different kinds of materials that they normally use in building technology at that time.
Let me say then, so essentially you didn't do any calculations on the structures themselves. So
And,
your understanding came through somebody else's calculations, and you were able to get a visual, if I can use the word fix, a visual fix on what structure should be.
No, I had to work pretty much as Frank Lloyd Wright did. And he had never been taught anything about structure either, you see. As a school course on it or something like that. But I often ask people who worked with him as engineers, like Paul Mueller, who built the earlier buildings for Wright, the Larkin building, and some of those. Then Mr. Glickman, who later was teaching at our school, had worked with him in his later years. He had built the Imperial Hotel, the Johnson Wax building with him, and the work since then. And they both told me the same story, that I said, does Wright actually calculate these things, or how does he do it? And I said, well, he developed his sense of proportion to the point where he could feel when it was right and when it wasn't right. And I think that is the way that I learned it, was thinking of it as what seems right proportion-wise, you know, in visualizing it or in imagining it or whatever you want to call that process. We can imagine almost anything, we can visualize almost anything if we train ourselves to do it. And that's really, I train myself to think of what looks right to me in proportion to what we have, and then I'd check it through Bill. And if he thought it wasn't, why, he'd tell me, or I'd expect him to, you know. But it isn't that I considered it right to the 32nd of an inch, but, you know, within the reasonable ballpark, what would you expect it to be? And later, Palmer Boggs has worked with me this way too, since I've been away from here. So I think it's a matter of intuition to a point, and a matter of imagination and thinking of what's appropriate, and lots of times of what you have to work with. If a man shows up, like Bill and I had to do the Hopewell Baptist Church together, you see, and that was made out of second-hand drill stem pipe. That's up near Edmond, Oklahoma. And they didn't have hardly any money, as usual, but they had a lot of second-hand drill stem pipe and different kinds of pipe. And we had to use pretty much what we could get, as long as it was on the safe side, of course. And so we really didn't get to design the pipe size, did we? We had to work from the
That's right.
pipe size otherwise, rather than just saying what we want to do and we'll find a pipe that'll fit it, you see. We had to take the pipe size we could get and work from that.
So essentially the pipe determined the size of the
Right.
church.
They had 2 pipe diameters.
But
and
we
that
could
was it.
use those pipes any way we wanted to, see, and that determined the design. So it worked the other way around. But
Bill, maybe he's being a little overly modest because about his knowledge of structures, because he took the license exam, you know, and passed it. That's how he got his license. And I imagine with a lot of help from Endicott and a lot of nights
Yeah, he did.
with the books, that he knew what he was doing, or he wouldn't have got through the exam, because they were very demanding, much more so in the past, considering in consideration of the structural abilities of an architect than they are today in our present license exam.
the license exam in those days, it took a whole week,
Yeah,
day and night. Supervision too, all the time. Even to go out to eat, or I mean, they wouldn't allow us to use handbooks or textbooks or anything.
And you see, since Bruce was thinking up these ideas, well, naturally, he didn't have time to carry these things on through the technical aspects, or what we'd call production today, what we'd call the production part of the office work today. And you see, the guy with the idea, such as Bruce, is irreplaceable. You've got to have him. But people like me, you can find, you see, and they're the replaceables.
well, that's what I was going to ask you, because in one sense, if the normal engineer would look at the drawings, now I presume these drawings were very much freehand, correct, that you presented to Bill?
No, I never made freehand
You
drawing.
never made a
No,
freehand
they were
drawing?
always to scale.
They were always to scale. You never sketched at all a drawing?
Always
then I'm
drew to
totally
scale.
Well, I have an idea he made sketches, but he did them in his head. You see, he didn't
So you
find it
sketched
necessary to put
completely
it
and
on
then-
I visualized them,
Yeah.
yes, in my head. That's not hard to do.
Then you went straight to the drawing board.
That's right.
All mechanical drawings. It's fantastic.
When he put it on the board, it was all there.
No,
Fantastic.
it's not fantastic. It's just what you're used to. I was lucky to be in a good office, you see. And it wasn't any great brains on my part. It was just learning to think and do things clearly.
Another thing we did that some people may not realize, and that is that many of these projects that we worked on were in different locations.
Yes.
Chicago, Oklahoma, and various other places. I would always get find out which code has jurisdiction, and we would do these things in conformity with the code. We never did ask for a variance on a code. And Bruce told me, he said, you know, I don't mind restrictions, because the restrictions really make it easier. He said, that tells you what you can't do right in the very beginning, so don't waste any time on that.
That's right. Did you get to visit the sites often, or was that an issue at all?
We did.
Yes. Oh, yes. We went out to the western part of the state there for the Cox House, remember? And Bill did a real fine set of aluminum frames to hold up precast concrete planks that had holes running in them, you know, the length of them. And you could lay those right on top of these frames, and that was the ceiling inside, and it was fireproof. And they wanted a fireproof house, of course, being out there where they had no fire protection. And so it worked out fine. There was no problem.
There was one interesting aspect, I think, about that house. These trusses were three-dimensional. They were quite simple, but they were three-dimensional. And the Panhandle was a little remote, you know, geographically speaking. It was even more so then. And we couldn't find a fabricator to fabricate these trusses. But the owner of the house, or Bruce's client, Julius Cox, had a tractor repair business. So we cleared an area back in the back of his shop, and I drew those trusses with chalk, full size, on the concrete floor, and his tractor mechanics then just followed those drawings and drilled the holes and put the bolts in and put everything together.
Did a good job.
Yeah.
Were there any other occasions in doing in, for instance, the Bavinger house where you actually worked full scale with what many people would call a prototype? And I think basically your buildings, in many respects, resemble real prototype buildings. There were no precedences for these buildings.
Each time you start over, I do. I think that you have to. I think you should always start with the thing slate clean as you can, and to work it out with the client, with them, not for them. Your fellow conspirator with them, you see, when you work with them. And we have no problem making them different. They would naturally be different, you know that.
So the difficulty is really making them the same seems to be more of a difficulty than making things different.
No, it's much more fun to work on them when you're trying to discover what each problem is, you know, exploring it.
See, this was an opportunity for me. I was probably doing more learning than I've ever done in my life before with this type of exposure, and I enjoyed it.
Well, I was doing learning too with him, and it all works together, you know. So.
Did Bill challenge you at any one point in terms of?
He'd tell me if he didn't agree. If there was anything that he felt wouldn't work, he'd tell me.
You know, these instances were so rare that I can't recall a single one.
That's what I was going to ask, if there was one that you can remember at all. Can you remember one?
Not particularly, but I do know that when he's talking about those discs over there, where I'm sure you must have counted on the skin of the bottom when you were thinking of the whole disc. I mean, as being part of the structure.
Well, actually, we didn't, you see, because they were on the bottom side, and that was in compression. Now, the top we did. That was the tension side of it, and we could use the skin.
Well, so you didn't have to use it there.
That's right.
You see, 9 times out of 10, an engineer would say, oh, you got to have that skin go all the way around. But I don't remember discussing it, but I do remember, I mean, I can't remember just what we said, but I can remember that I asked you about that, and you said it wasn't needed. That was good enough for me. I wanted to see the structure of it anyway. I thought it looked good. With most, when I'm working with not most, because I don't work with very many of them, but many times the engineer, or the structural engineer that the architect works with, is a problem to work with, because they have learned to design a traditional kind of footing and foundation and column and beam or something like this, and that's all right. There's nothing wrong with that, of course. But with this man Endicott, my big problem was that I had to look. Sometimes I had to argue with him about why do it, you see. Like we were working on the Boston Avenue Methodist Episcopal Church South, quote, the name of the church in Tulsa. And I designed it, and I was only 22 then. It was done in 26. And there was an awful lot I didn't know. But there still is. But anyway, he showed me the way he thought we should arrange the columns underneath the big room above, the auditorium. And this room in the basement was limited in height that it could be, and also it was supposed to be a big open space where you could have banquet tables and theatricals and different things set up in there, you know, multi-purpose with a kitchen layout. This whole church had one of the biggest, well, you might say, social aspect to it, you see, in the way of education and the way of entertainment, other than just the church itself. And so I knew they wanted this room to be free of any obstructions. And so when Endicott showed me where he thought we ought to put the supports for the room above, I about flipped because he had posts all over the place, and I said, you can't do that. We have to have all of this space free to move these things around. He said, oh, don't worry about that. He said, I said, well, if you're sitting over here and you want to see the stage over there, how are you going to see it? He said, well, just move over a little. And I said, yeah, but the other guy's going to be moving over too, and you still won't see it. Well, he said, there's no point in going a lot of money down there, and that's just a basement. And this really got me then. I said, oh, it's just a basement, but just the same, it's got to work just like any of it, doesn't it? And he said, yeah, but there's a reasonable place where you spend money, and you're going to cost a lot of money, and you don't have the height to put it up above there. It had to span 120 feet, and you're going to have to put something under that to hold it up, you know. And I said, well, yeah, you're just like all engineers. I said, you always talk about the wonderful things you can do with steel and concrete and all, and still when you come right down to it, the first thing you want to do is put a post under it. And that's as old as the neighbors. I said, I think you, of all people I know, could figure out something there that would work better than that. And he said, oh, don't worry about it. A few posts won't hurt anybody. But he was kind of shamed by what I had said, you see. And next morning when I came to work, he hadn't even gone home that night. But he had laid out the place and without any posts. So when I came in the next morning, he says, well, here's your auditorium, and there isn't a damn post in it. Says, who says we can't do it? So I learned that I could use that once in a while. I had to be very sparing. But another time was up on top where the preacher had said he didn't want to have a cross on it because he didn't want it have to say it was a church because it had a cross on, you see, that it should look like a church whether it had a cross on or not. And so I thought, well, we ought to top it out with something on top of the tower, you know. And if he doesn't want a cross, why, what would we do? So I thought, well, we'll make 4 fins of glass. They'll be held in steel frames, very light, and be about 35 feet high, actually, and it'd be up there where about 25 stories off the ground, where it gets a lot of wind there. And I had it in an X shape in plan to the square of the top of the tower. And he assumed that those crossed or intersected each other, you see. Well, even I knew at that age that they'd be stronger if they did, you see. But I wanted the sky to come down in between these X parts. And I knew I was asking for something that might be pretty hard to do. And so I said, you realize now that these aren't supposed to touch here. And he said, they're not. I said, no. He said, well, what do you think's going to hold them up there? And I said, that's for you. You're the engineer. I said, they're not supposed to touch. He says, why not? I said, well, we got to have the sky come down through there. And he says, oh, hell, there's a lot of sky out there. Why do you want to have it run down that little place there for? And he was always very matter of fact. And I said, well, of course, if you can't do it, why, we probably have to do something else. But the main reason I don't want to have it touch is I don't want it to look like a spike on a helmet or something up there. And I think it ought to open up into the sky rather than to look like a spearhead, threatening the sky or something. So he says, oh, that isn't going to do that. And, and don't worry about that. And you can't have those things apart like that. And I said, well, then in that case, we just forget about them and do something else. And that was another time when I came back the next morning. He'd worked it out. They've been there now since that time, and they're still there. But he had worked them down into the tower where the belfry was, and they were not in the way of anything, and he could have them held firmly below and coming up through. Even with the terrific wind pressure they got on them, they're still there. But like I said, I had to use child psychology on him sometimes to get him to do things, because his first reaction sometimes was, well, why, but if I could give him a reason, a good reason, then he was capable of thinking about it and really working it. And of course, I wasn't experienced enough. I didn't know. I was just a kid, and I didn't know whether you could do it or couldn't, except it seemed like you ought to be able to. If science was as wonderful as he thought it was, and sure enough, it was.
I worked for an architect before I met Bruce that had become paranoid over this issue. In fact, he was so bad that he designed 2 buildings. One that he liked, and another one for the engineers. And he would hide the one that he liked in a desk drawer, and I think I was about the only person he ever showed them to.
Yeah.
That's quite a shame. But it seems, you mentioned, if I can change a little bit here the direction, you mentioned the word reason. Now, when novices look at your work, and they seem to express that it's a little bit flamboyant and flippant and bizarre and things like that. Now, in my short time from talking with both of you, it seems to me that your buildings really come very close to being a pragmatist's building. Probably your most famous building is the Bavinger House. Can you explain to me some of the decisions and the reasons that you had, both of you, why that house is the way it is?
Sure. I think you ought to be able to explain any house, any building you do, according to reason of some kind. The reason may be aesthetic, it may be structural, it may be environmental in some sense, or all kind, or lack of money usually, or things like that. Bill Bavinger had this site along next to next door to your place, didn't they? Part of that same track, wasn't it, right?
That's right.
And there was a kind of a stream effect through there. And I knew that Bill was going to, Gene, excuse me, going to build his house himself, because he said he had to. That's the only way he could swing it. And so I thought, well, it'd be nice, the site itself was along the, it seemed to be the nicest part of it was along by the stream there. And the trees were thick all around there. There was a kind of a place that had been, somebody before, he owned it, had excavated some earth around a curve sort of shape. Just happened to be a curve on the shore of the stream, bank of the stream, I guess I'd say. And it was this curve, and then I realized that he wouldn't have to dig any out if he could make, or very much out, if he used that where it was already dug out, you see, in that curve. And I realized if you extended that curve on, it might resemble pretty closely a parabola, a spiral, logarithmic spiral of some sort. And so I thought, well, why not just let it be that? And of course, he'd already told me what he wanted, and she had too, in the way of inside the house. And they wanted the very close identification with the site, with the not the rock that was on the site. They wanted to use that, and the water, and the whole site was important. They didn't want to have a lot of space that was all boxed up into separate rooms with separate doors and windows, and they said they would sacrifice some of that if they could have some change of level. And they wanted to carry a great deal of planting inside the house, more than most people did. And he could make a plant grow in under one of these chairs in this light, I'm sure, if anybody could, because he knew a lot about it, and he knew very well how to take care of that. And so if I allowed this thing to become a spiral, which it seemed natural in the way the land laid there and all, and what had been already dug out, then we could have the stone make a wall. It would be inside and out, and the same material, and wrap around into the spiral shape, and it would be low and broad in space where you entered it, and as it wound up and got higher, then it would be narrower and higher, you see, towards and then the pole would escape out the top. And the reason for the pole would be to have something to hang the roof from, independent of the walls. And of course, we knew we'd have to reinforce the walls with steel some way. They were quite high at places to get the steel in, so we were sure of that. And then one reason for hanging the roof, besides, was to keep the interior free from the columns, and also to hang these areas that were combinations of furniture and rooms in the space. And the stairway could hang from, everything could hang except the stonework, the roof, everything else, from this one pole that would be a 6-inch drill stem pipe. and that he had traded for. He was a horse trader, and he had to be to get the thing built. And so Bill's problem then, of course, was to work out a way to, we didn't need a lot of depth to go 36 feet, did we, across where it was low and broad, if we hung it from above, you see, and not depend on trusses and all that jazz. So then didn't we first plan on just using cables?
Yes, I think so.
Regular cables. And that would be too expensive for Gene because he didn't have the money to buy that kind of cables that we had thought of using. And so then it ended up, he found, or you did, or somebody, that the war surplus, World War I surplus, which was practically extinct by then, in 49, 48, 49, along there. They could buy these struts for biplanes that sort of X-shaped, you know, where they had two wings to the planes, and they could hang. They were the finest chrome steel you could buy, and kind of, instead of circular in section, they were kind of pointed ellipse shapes in plan. And then he had to determine how to put them together and how to work them with the pole above, and how to have the dead man to hold the pole. Well, he can tell you a lot more about this than I can. I don't know why I'm mentioning this. But anyway, that was the major structural thing, and then hanging the parts in there that acted as the living units, the visiting bowls or the sleeping bowls or whatever you want to call them. So that's the way it all took shape from that point, and you know as much about it, Bill, as I know.
Now, that was very interesting, too, because Gene Bavinger found these airplane struts that Bruce mentioned. And, of course, that solved the corrosion problem. Here they were, triple or quadruple chrome implanted and made for lots of exposure. And they had built-in turnbuckles. But since they were surplus, I didn't know what kind of steel they were. And so we just took one of them into the lab and put it in a testing machine and loaded it until it broke, and then we knew what it would do. So we used, as you normally would, 45% of that for the load carrying capacity, and they worked out great.
I was going to ask you, what was your expression or thoughts when you first saw the drawings from this house?
Well, I was almost immune to shock by them. One thing that I would like to say about Bruce's work is that I never was able to really exploit the intrinsic strength that the building had. The Bavinger House is a good example of this. You see that curvilinear plan form that he had, this logarithmic spiral, is a very stable structure within itself. You find it in nature. You find it in the seashells and that sort of thing. And but I didn't have enough math capability, and couldn't find anyone else who did, I might add,
Not many did.
to analyze it from that point of view. So I had to use the conventional free body methods of analyzing these structures, and then really eat up the library when the math got tough, so that we could get through. And our primary concern, of course, was to have a safe structure.
That's excellent.
And execute the idea. And as I say, I can't remember an instance when it didn't work out.
Well, I think
And Gene himself put in more steel as he went up, too.
Yes. What you call fried steel.
Yeah, that's all right.
The higher the scaffold, the more he put in.
well, I was
He
gonna say,
realized he was getting up there, you know. And the tallest part of it, about 3 stories high in there.
To save money,
Yeah.
he bought some empty boxes that were surplus, wooden boxes. And rather than build scaffolding, he would pile these boxes on top of each other. And he had boxes 40 feet tall, stacked one on top of each other. And that's when he began to put more steel in the wall.
And then he also had his sewing machines, you remember those?
Yes.
They were used to, when he was down low, he started in with some old sewing machines, those treadle types, and they had little drawers, you know, and we incorporated the drawers in the bathrooms and various places. And a big walnut tree blew over in Oklahoma City, and Gene had bought an old truck that wouldn't run, learned how to fix it, and went up, or he asked these people in Oklahoma City if they'd let him have that tree if he'd haul it away. They were glad to get rid of it. And they said, sure. So we had the finest walnuts you could ever want, 2 and 3 inches thick, you know, that and could have had more if we wanted it, you know, we could use for kitchen tops and buffet tops and all that sort of thing. And we had to use bowls, these bomber blisters from the old planes, kind of hemispherical. And we made light fixtures out of those, and we also made wash basins out of them. And a lot of this was not just to see how ridiculous you could be, or what they call ad hoc nowadays, of using materials for things they're not supposed to be used for. Well, we were doing that, that's for sure, but it wasn't, it was the idea of trying to do something eccentric. It was, I'd learned when I was in 3 years of service with the Seabees up in the Aleutians. I had to work with materials I could get, you see. And so that meant that in this case, we had to work with what we could get, because he didn't have the money to have others.
But I think it's an interesting point, though. In one sense, you violated the titled function of many of the materials, but you worked with the characteristics both of the materials and the forms in your houses, and that's why you could come up with new functional uses.
Right.
And I think it takes quite an intelligent and also a human being with sensitivity and I think a sense of humor to do things like this. And I think both of you.
Helps to be broke, Bill.
I'd like to, if possible, close on this point and see if we can go ahead and take a short break here.
Sure.
Thank you.